Hello, I am Math Coach Parker. You can call me Gary. And I heard you were interested in learning about scale drawing. So let's check it out. So there's this artist and he's going to make a sculpture. So let's make an artist. He's got this palette of colors here. Paintbrush. And he's a happy artist. He's going to make this crazy sculpture and paint on it. And it's going to be pretty big. It's going to be, let's say it's going to be around this big-ish is his sculpture. And it's going to be even bigger than that. Let's make it really big. Really big. It's going to look something like this here. It's going to be a parallelogram, right? So I need parallel sides. So that side's it's off the screen a little bit. Let's fix that. This side, is that about parallel there? Yeah, okay. And how big is it? Good question. I heard he was going to make it 8 meters. So a tall human is like 2 meters tall. So this is like 4 humans across. Okay, so maybe he's too big here. Maybe it's a little bigger than that, but let's get 8 meters there. So I know that's going to be part of this drawing here, 8 meters across there. That's pretty big. Now he needs to do some design work, and often we scribble on a piece of paper. So he's going to whip out a piece of paper, right? A piece of paper maybe is about this big, and he's going to redraw that shape on the piece of paper. Like that. So he's going to make the scale drawing. Now, the one he makes on the paper has to be the same shape as the real thing. That's called a scale drawing. And so he needs to take this, have exactly the same shape, but just smaller. In his smaller picture, he wants that on a regular piece of paper, this is probably about 10 centimeters. So we got to shrink 8 meters down to 10 centimeters. So to shrink something, you multiply by a fraction that's less than 1. How would we take these numbers and make a fraction that's less than 1? Well, we would take the small number divided by the big number. So I take the small number and divide it by the big number. And the question is, you look at 10 and 10 seems bigger, but it's not, right? Because this is 8 meters. And let's see, there are 100 centimeters in a meter. So 8 meters is really 800 centimeters. So that's the bigger one. So my scale is going to be 10 centimeters divided by 800 centimeters. The units have to match when you make your scale. Otherwise, it really doesn't work mathematically. And then once I do that, like the centimeters kind of disappear, and then 10 goes into 880 times. So I can say my scale factor is 1/80th. 1 out of 80 is my scale factor. All right. Now that tells me how to take the length of this and make it smaller. It also tells me how to make this diagonal over here smaller. How would I make it smaller? I would make it 1/80th of its original size. Okay, so if you think about the area of this big one here, and maybe I shouldn't talk about the diagonal, take that back. That is the diagonal. Area, you need the height. So let's draw in a height here. Let's use red. The height is you go straight down from the top to the bottom at a right angle, right? And this diagonal line ain't straight down, right? So this is my height over there. Area is whatever the base is, base times whatever your height is. H-E-I-G-H-T on a good day. All right. So my base, well, that's the same as the top. That's that 800 centimeters. And my height, I don't know what that is. He didn't tell me what the height was. So, but what I do know is to get the smaller one, for the smaller, I'm going to take my base, original base, and multiply it by 1/80th. Right, so let's see what happens there. If you whip out a calculator and you take 800 times 1/80th, you should get 10. So you can whip out your calculator and check that. And the height, I'm going to have to do the same thing. Otherwise, I squished it. It's not going to be the right shape. So for the height on the smaller one, I have to take the height of the big one and multiply that by 1/80th also. So if you put all that together, then the new small area, right, that's this area up there, is going to be the original base times 1/80th times the original height, right? Area is just whatever your base is times the height, and my new height is the old height, also times 1/80th. So it turns out when you switch from length to area, that scale factor turns up twice, right? I got it here, I got it there. So I'm going to clean this up with a little bit of algebraic jiggery pokery here. When we multiply numbers, it doesn't matter what order we multiply in, right? 2 times 3 is the same as 3 times 2. So I'm going to reorder that multiplication. So I have 1, 2, 3, 4 things multiplied. I'm going to rewrite it as I'm going to put the 1/80th, this one, out front. I'm going to take this 1/80th at the end and put that out front. And then the base and the height are just chilling here at the end. Times height. And this base times height is the original sculpture. And then here I just end up with the scaling factor times itself. 1 times 1 is 1, 80 times 80 is a big number. Ooh, what is that? 8 times 8 is 64 with 2 zeros. So 1/6400, right? And think about that. You could fit a whole lot of those in here. How many? 6,400 of them. Whoa, that's kind of cool. All right, so that's the trick there. We have to consider both the base and the height when we compare the areas. So although the lengths are 1/80th smaller, the area is 1/6400 times smaller. Whoa, cool. I hope that was helpful. Take care, do good math. Adios.